Okay, hello everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. No engines, no libraries. We cover the complete range of game development here. Nothing is left out of the process, so no matter what part of game development you are interested in, we will cover it. That is a guarantee. That is just how we do things here. And right now we are working on sound mixing. We have already written our sound mixer. We have already written some features for the sound mixer, such as sound streaming. We have already done volume interpolation. We've done a lot of stuff in the past week. It's been a whirlwind, it's true. But what we have not done yet is allowed the person playing the sound, the person requesting or queuing a sound to be played, to be able to set the frequency of that sound, right? So what we would like to do is we would like to have some ability for the frequency of the sound to be changed dynamically. And let's talk a little bit about why you might want to do that. So if you think about what happens in a game, right? So typically, you know, this is sort of, here we are on day 143. So let me just put a little title up on there. So if you think about what happens in a game, a lot of times what we're talking about when we're talking about playing with sounds is a lot of times there are sort of triggers or events or periodic ambient events even that are trying to create some kind of an effect to reinforce an activity or an action, right, in a game. And so examples of this might be, you know, I've got a little dude, you know, and the little dude is running around. And whenever he jumps up into the air, you know, we want to play a jump sound or something like this. Or whenever his feet touch the ground, we want to play a footstep sound, right? And so we've got all of these things that are being sort of fed into the sound system. And the sound system is supposed to play sounds that reinforce these things that are going on. And it's true even in an ambient sense. Maybe you're in a place, you know, with a tree or something like this, right? You know, kind of the world's worst tree here. All right, don't blame. Okay, you know what? Just forget there's not a tree. I lied about that. There's some kind of ambient thing going on. I was going to say like branches crackling or something, but the tree was so ugly that I felt I had to come back from that. You know what? Here we go. Let's go with a pine tree. That should be a little easier on the art skills there. So you know we've got a little tree here, and the tree is going to like sway back and forth. And so what we want to do is play some like branches crackling as well, right? So that's not really an active thing that's necessarily happening, but we've got like sort of this forest theme, and there's going to be some branches, crackling branch and sounds or something, right? So all of these things are going into the sound system, and of course, in a perfect world, we would just have some way of generating a footstep sound all the time that was unique and different and interesting and all these other things. But the reality of game development is that oftentimes there's a fixed budget, and that budget may be determined by how much you can afford to pay to have the sounds created. That budget may be dictated by how long it takes to process the sounds and put them into production use or something like this. It may be based on how much room you have on a console for storing the sounds. It may be based on your download footprint. There's all kinds of reasons why you can't just have 8 billion footstep sounds, unless of course you're the witness and dedicate your entire budget to footstep sounds. But most of the time you're talking about limited space. So maybe you have 5 footstep sounds, let's say, right? For running on a particular thing, like grass, right? So I have grass footsteps. And I have 5 grass footsteps. Well, if I have 5 grass footstep sounds, and I play them over and over again, so as the guy's running, he's taking, you know, at least 2 or 3 steps a second, right? I am going to hear the same grass footstep sound many times a minute, right? And that sort of repetitive nature of that sound can get very grating, especially in a circumstance where you're trying to create a realistic sounding soundscape as opposed to perhaps a gamey sounding soundscape. Like, you know, if you were trying to evoke an old arcade game, this would not be concerned because they were supposed to have repetitive sounds. If you're trying to evoke a realistic outdoor scene of some kind or something like this, not so good, right? And so one of the things we could vary would be the volume, certainly, because our mixer has the ability to vary the volume. So at least then we add a little more variability as the footsteps go. There's some variance in volume. So in addition to 5 different footstep sounds that might trigger on this grass, we have some volume. But what would be nice is if we had a little more range to play with there. And so that's really where frequency modulation, is good. Frequency modification comes in, where we can sort of pitch shift our footsteps a little bit, up a couple half steps or down a couple half steps, or semitones as they're called. Not talking about huge frequency shifts here, but we're just talking about if a sound is a particular pitch, maybe pitch shifting it up a little bit, pitch shifting it down just a little bit, right? We'd like to have that in there as another way to get variability out of our soundscape. And in some cases, we may even tie that variability to something in the game that the player can perceive. So for example, maybe a boss monster, as you hit them and they take more damage, the frequency of the impact goes down or up, so you can hear a little bit of feedback as to how you hit them, or who knows, right? You can think of reasons why, in addition to just creating a less repetitive soundscape, that frequency can be a nice, easy way for you to put more interactivity into the soundscape than if all you had was volume, right? And so these two things are pretty nice things to have in a mixer, all told, and they're pretty easy things to add. So that's why I focus them on them as things that I think if you were talking about a sound system, it's probably worth your while to implement these because you'll get a lot of mileage out of them. Now, other things you might not get very much mileage out of, such as like all kinds of advanced filters or something like this, because you may just not have a lot of cases to use them. But I think almost every game pretty much uniformly can get a lot of mileage out of volume and frequency, to be sure. So, I guess what I'm saying is their bang for the buck is pretty high. So, okay. So if we have a sound, right, we've talked about how the distance between peaks in the sound, right? So basically this wavelength here, right? This is the wavelength of the sound, if you will. This sort of peak to peak measurement. You could also think of a half wavelength as being like peak to trough or something. The speed at which that is occurring in time, right, this is time, determines the pitch of the sound, right? So it doesn't really even matter what the crazy waveform is. It's the speed of the oscillations contained in that waveform. And there may be many of them overlapping, right? We discussed the fact how they add. But those overlapping oscillations are what your ear perceives as pitches, each individual one having certain pitches, and there's pitches that evolve over time and so on. So what we want to do if we want to change the pitch of a sound is we want to speed up or slow down the rate of those oscillations. So the distance between these two things we want in time to become shorter, right, or longer. And if it becomes longer, that will shift it down in pitch. And if it becomes shorter, that will shift it up in pitch. That's just fundamentally how the sound worked, as we discussed on the episode where I introduced sound a couple days ago. So, as I said on that episode, and I'll just remind you quickly of it, I won't belabor the point here, there are a couple different ways to do this. Some of them are very, very expensive, and they're designed for purposes where you're trying to do large-scale pitch changes without changing the amount of time the sound actually takes, right? So you have a sound that's 1 second long in duration when it's a certain pitch, and you want to shift it up in pitch but have it take the same amount of time. Okay, that's a fairly complex operation. There's multiple ways of doing it. The traditional signal processing ways and wavelet ways are kind of crappy. There's newer ways now, such as like cylindrical resampling and stuff like this, that are way, way better, but sort of less well-trod. But point being, they're very much more complicated. They're much more involved than what we're doing. They're not prohibitively so, but they're much more involved. Thankfully, you don't actually need any of those for the kinds of pitch shifts we are talking about. We're talking about just minor pitch changes. And for minor pitch changes, we don't care if the sound gets a little longer or a little shorter, because it'll still be roughly, if it took a second, now maybe it takes 1.1 seconds. We don't really care. We don't really care if the footstep sounds a little bit longer, right? Because you really won't perceive that difference in practice. You'll just hear the pitch being a little bit different. So for that, what we're going to do here is totally fine, which is just playing the sound itself back faster or slower. And so fundamentally, the thing that we have to do is, we've got a sound that's represented digitally. So, we're saying that it's this smooth waveform, but actually, right, we only really know about the waveform as a series of sample points where it crosses fixed slices, in time, right? And we're sort of thinking about it just as these samples. These are the samples of the sound, right? We have a sample buffer, right? It's filled with int16s. Those int16s are encoded by thinking about where a waveform passes through vertical lines in time, instants in time. At this instant in time, where would the waveform be? Those go into our sound buffer. That is our sound we play back. What that means is that if we want to play back this sound at a different rate, we do not have the luxury of simply resampling this curve at whatever rate we want, because we do not know what the curve actually is. We don't have the curve, we just have samples. Those samples do not represent an actual curve, they represent just a piecewise linear sort of approximation of that curve, right? If we looked at them this way. It's only once they are reconstructed by a speaker that they turn into something that approximates the actual oscillating sounds. And there are artifacts even that happen when you do that, given the fixed sampling frequency. And that gets into a lot of signal processing kind of nonsense that we probably don't need to cover here. And I'm the wrong one to talk about it anyway, because I'm far from a signal processing guy. But the point is, looking at this function, right, all we really have is this piecewise linear version of it. That's all we know. And so, if we wanted to do a smooth resampling of it as if it was a curve, we'd have to try and guess about what that upsampling might look at. And there's actually ways you can do some things because it is sound where you can upsample in slightly better ways. But since we are pitch shifting such a small amount, it actually is fine for our purposes to assume that we have this piecewise linear version and just resample at the piecewise points. Now, I know signal processing people are probably horrified at that because it's not really the signal processingly pure way to do it. But again, for small pitch shifted, it works really well. And it's very, very quick and easy to write the code for it. So it's good for a real-time mixer that we don't want to spend a lot of time. We don't want to take a lot of CPU time doing its work. It's pretty handy for that. So what we want to do now in the code is, rather than playing back sounds by just outputting those fixed slices in time like we were doing before, we would like to make something where we can actually do a lot, basically the same thing we did with the bilinear filtering in images, like we did for our rasterizer. We want to do the same thing here, only because we only have one-dimensional data instead of two-dimensional data. Instead of a bilinear filter, it's just a straight linear filter. So you remember, for pixels, we were trying to interpolate between four corners, right? We were trying to say, like, we want this. And so what we did is we interpolated to here and here first, and then we interpolated between those two to get this. That's why it's called a bilinear filter, right? Is because there's two, right? There's two steps. First, we do a filter to produce new points, and then we do a new one, right? It's two stages of a linear filter rather than a single stage. This, we only have two things to begin with, so we're just talking about a straight linear filter. We're just doing that first one. And you remember, I said it at the beginning of the series, I'll say it again, p prime equals 1 minus t, p0 plus tp 1. That universal linear blend equation that comes up over and over and over again. I think I said something like, if you only had one equation that you could take with you to a desert island for programming, it is the one, because, man, it is just the building block of everything in games that we do, because it is a perceptive medium, and linear blending does so many important things for people's perception of what's going on. So, that is really the thing. It's going to come back here because we're doing exactly that same thing. That first step, this blend right here, we're just doing the same exact thing for sound. So what we want to do is be able to produce a floating point version of where we believe ourselves to be in the sound. We want to do the exact same thing we were doing with the bilinear filter, where we floor and ceiling it to get the two locations that we would like to talk about, right? We will then figure out what the samples are at those two locations and interpolate between them based on the fractional amount that's left over after doing that floor operation. Okay? So that's really what we're talking about. That's all we're trying to do. And so what we want to do is make that happen. And again, nothing at like literally zero, nothing that we do here will be different from what we already did in the rasterizer. It's just a simpler case because now we're, instead of having to do square blends, we're doing just line blends. So once we have that, once we have the ability to take a sample at an arbitrary place in a sound, rather than having to only take samples at these predefined points, then we have the complete freedom to change the speed at which the sound plays back, because instead of doing something where like t plus equals one sample, right, basically every time, we can just do t plus equals, x samples, where x is any value, like 1.2, 0.9, whatever we want, right? And so that will allow us to change the pitch of the sound by changing its duration. And again, if we just keep that to a pretty limited range of pitch bending, then we won't really hear any objectionable problems to that because the length of the sound won't be changing appreciably. All right. So let's get started. Again, today is day 143. So if you would like to follow along at home with the source code, if you have pre-ordered the game on handmadehero.org, you should be able to download the source zip. Inside there is all the days, and so day 143 is what we're on today. Unzip day 142 as the source code, and that is what I've got here. So if you want to match up with me, that's what you want to use. Okay, let's get rid of that. Let's get a command prompt up here. And all right. So let's go ahead in here and start by loading up our audio mixer and taking stock of where we are at. So the first thing we could do, right, to get started with this is that if you remember what we did in the case of the bilinear blending for rasterization, you remember the first thing we did is just not do it. Instead of doing bilinear to make that nice smooth effect that doesn't, so you don't see all the crispy little jumpy lines and stuff, we just first started out with saying, you know what, doesn't matter, let's just do a point sample. We'll just sample it at the nearest place, and we'll just use that to get things started. And then we implemented bilinear to make a nice, smooth, clean version after that. So we can do the exact same thing here. What we can do is we can start by actually writing it so that we do use the floating point location in the sound to pick where we are reading from, so we can change its speed overall. But we will just pick the closest sample rather than actually interpolating. And that should, in theory anyway, lead to some objectionable artifacts that we can hear. Maybe it will, maybe it won't. It depends on the sound, certainly. But hopefully we can hear them, and then we can implement the linear filtering, which will take them away. OK. So let's go ahead and do that. Let's go ahead and take our Handmade audio here and say that a playing sound sample played. First thing we're going to do is upgrade that. Instead of being an int32, which is the sample count, we are actually going to make that a real 32, so it knows kind of where it is in the samples more specifically, right? So let's go ahead and fix sort of the warnings that we will get there. So in terms of samples remaining in sound, all we have to do there is do our round real 32 to int32, right, in this place, which will round out that samples. And then the same thing would be true here, right? I'd round it out again. There we go. I could do something as well, like first sample, S32 first sample index, and that sample index I could just take this way, first sample index, like so, and then down here, first sample index. And since it only gets updated at the very end, right, it should not be a problem. So samples played is never touched anywhere else, right? So it should be all good, right? And this guy needs to use it as well. So, okay, so if I do that, nothing should change. We should still have the same thing we had before, right? all good. So now what we want to do is say, all right, let's allow that to be modified by some other amount than just 1 per sample. So if we do that, what we need to do in here, right, we can no longer just say sample index, and this for I loop obviously is going to look a little bit different, right? So what we actually want to do here is we want to say that this sample index now is actually going to be a real 32, right? And what we want to do is go ahead and take that out now. I guess I probably should have not actually pulled it out here. I thought I was doing a helpful thing, but it doesn't look like I actually was. Anyway, we have real 32, that's the sample index. We want to go ahead and make sure that that stays kind of within bounds there, so we're going to still clamp it that way. And then when we do our sample index, what we'd like to do here is we'd like to do an accumulator. I'm going to move it out of the for loop just for now. I'm going to put it down here so when we can see that we do volume, we can also do desample, right? And then desample is something we can just set for the now to equal to 1.0, and that should be good. So now what we need to do is figure out what sample index we're actually on. And so this is going to be something more like this is like a sample position, really, right? It's not really a sample index anymore, it's a sample position. And so the sample index is actually going to have to come from doing that round, right? And then we actually have a sample index that we can use to look things up. Now, oops, cut that there. So now if I play, again, hopefully it's the same. And you know what, I wonder if we can, I'd like to have the sound keep playing for now, at least while we're in debug mode, when I switch back to the editor, because since we have live code editing, I want to be able to hear it when we change things. I wonder if we can just tell Windows in the platform layer to not maybe do that, as much. I'm not really sure. Let's see about the primary buffer. What did we say in there? I guess is there some way to set it to a cooperative level? Maybe this could be set to something else. I feel like maybe that has something to do with it. I don't remember this stuff offhand, but oops, that's not what we want. Let's see. This is not. This will be muted. Would this level also be? Yeah. So this is not. I wonder what we can say to just have it play a little bit more nicely with what we're doing, because I would like it to not keep forcing our application to not output sound in the case where it wouldn't work. Yeah. I don't know. Let's see if we can see here. Direct sound output when not focused. Let's see. Yeah. It's looking like it might take a little bit more while, or I could go read some of my own source code to see what actually happens in there. I guess that's not to be done right now, because I'm afraid that'll just be a rat hole that will go down. So maybe what we can do is let's just say, I will try also, I'm wondering if I should try just setting it to normal for now, just to see what happens. Nope. So it has nothing to do with that anyway. So we'll have to take a look in DBS Cap's global focus. I wonder why we've got a to-do on that. Was that like a hint to our future selves? Let's see. An application can continue to play its buffers if the user switches focus to another application, even if the new application uses direct sound. So DBS caps global focus, it looks like we did kind of do a hint to ourselves about that. So I wonder if we want to do that. Well, doesn't look like it worked anyway, so that doesn't perhaps matter as much. But yeah, because this is the this is the DS buffer. Oh, but that's not. No, it is that. I assume. Create sound buffer, set format. Just cut current position. So that's a buffer description. So I wonder if maybe we can take a look at it a little bit more specifically here. Let's take a look at this structure. Come on. Guess we'll have to get it off Google servers there. The flags, yeah, so that should have done it, I guess. But it looks like maybe global focus, what does it say here? The one exception is if you switch focus directs on an application that uses the DSL right primary flag. In this case, global sounds for applications will not be audible. So it sounds like that should have worked, right? With this flag set, an application uses direct sound continue to play. So I feel like that should have worked. Maybe we need to set it on the secondary buffer as well. But I don't, that seems a little odd, but I mean, we could try that as well. And then I guess we'll just give up for now and take it offline. Aha! So I guess setting it on the secondary buffer works. I wonder if I can remove it from the primary buffer then. We can. All right. So I'm going to go ahead and say that right here, I'm going to say to do in release mode, should we not specify that so that we don't play sounds unnecessarily? I wonder if we should do that. In fact, what we could do here is something like pound if handmade internal, right? And in the case where we know it's an internal build, we will go ahead and OR that in so that we can play sound all the time. All right, so that didn't take too long. Sometimes Windows things can be a bit of a rat hole, certainly. But yeah. All right. So since we have loop live code editing, we can kind of play around with this stuff. I guess since it's sound, we don't even have to see it, so maybe that's fine too. I don't even need to play with the Emacs window to get it in position. So let's go ahead and take a look at what we need to do here to be able to change D-volume to something else, right? So the problem here that we have, if I want to change this, let's say I want to change this up to double speed, right? One of the problems that we'd have with changing it to double speed is samples remaining in sound is not going to be correct anymore because this assumes a particular rate, right? So what we really want to do is we really want to do this math in a little bit different way, like, you know, sample time remaining or something like, or float sample remaining in sound or something like this, right? Where we first compute what it would actually be if they were playing one at a time, but then we take into account the D sample. So how long, you know, will it take, given how fast we're moving through it, to compute a different amount, because this loop will be incrementing by D sample, not by 1. So we want to go ahead and divide by D sample to find out how long it will actually take us to go when we get our sample remaining, right? And then we can round that up to figure out what that would be in actual terms of sample space. Now there's some edge condition stuff that we're going to have to think about there, but for the moment we don't have to worry about that too much, right? Looks like I didn't define an R32, huh? By the way, I'm really digging this new, more concise version. For people who don't like it, I'm afraid it's going to stay. I think it's going to stay. I've been liking it at work. I've been liking it here. This set right here is way better than my old set. So I'm feeling it, if that makes sense. It's always so funny. Oh, it didn't like that. Oh, you know what? So here's an interesting thing that we have not addressed yet, and we should probably put this on the to-do list. We really don't have to worry about it now, but I wanted to mention it. So one thing that we haven't done with the loop live code editing is now that we have multiple threads working, those threads are in the DLL that's going to get unloaded. And so we have to make sure all the threads have spun down before we reload our live code, which we are not currently doing. And so that's, again, doesn't create a problem for the game because the users will never experience a crash because of that, because they're not developing the code and live editing it. But we are, and so one thing we might want to do here is put in something like flush all thread queues before reloading DLL, right? And that is a thing that we will hit occasionally. We haven't hit it very often, but it's totally plausible, right? So yeah. So let's take a look here in Handmade Audio. Let's slow this down a bit. So that sounds a little bit wrong to me, even modulo the artifacts that will come from not sampling. So I think we've got some bugs in the computation here, so I'm just going to go through this a little bit carefully before we move on to the linear blend. That's just intuition on my part. It just sounds more wrong than I'm expecting it to sound from having done this sort of thing before. So there's really no way otherwise. If you were doing this for the first time, you wouldn't know. You could be like, well, maybe that's for the linear blend, and then you'd put in the linear blend and you wouldn't be sure. But so if I take a look here, we've got the sample position. It starts at samples played, and the sample position that gets added by desample every round, right? We round it in to figure out, we round what the sample position is there. Oh, but our update also has to take, do the proper thing here for sample position. So samples played should actually be set to sample position right at the end of the day. So what we probably want to do here is do something more like this, where this is a while loop, right? And we go through the sample positions like so. And now when we're done with that loop, we can just use sample position directly, so that will be correct now. So, still a little bit odd. Like, it has that very odd breaking point up around 1.4 where it starts to be more than one sample. So I feel like we've got some kind of a nasty, like, I don't think I'm quite still doing it right. Right around that rounding threshold. So we got the desample. Let's walk through the code once and see what I'm missing. And if we can't see anything that we're missing, let's drop down to the bugger and step through it and see if we can see what's going on. So right now we make sure that samples played has to be greater than or equal to 0 because we're not allowing pre-queued sounds yet, but like we said, in the future maybe we will. First sample index is just something that we're trying to use to figure out how many more samples we have to go. So we're taking the sample count minus that first sample index. Since that's not a reused value, I can actually go ahead and now make that be something that just happens in line here, like so. So that's good. Get rid of that. So we start out thinking that we're going to mix all the samples in the buffer. We then say, how many samples are there left in the sound? Well, the number of samples that there are left in the sound is going to be however many samples are actually left divided by how fast we're going through them, right? So, if it was 2.0, that means we would get through it in twice the time, so there'd be half as many samples remaining to actually pull from, right? We would then round that to figure out what the actual number is. In the future, we'll probably, do something a little more fancy there because rounding is not really super appropriate necessarily. We haven't thought through what happens at the end condition there, but for now it should be fine. We then say if the number of samples that we were going to mix is greater than that number, we use that number as the number to actually try to mix. The volume, we're not actually interpolating yet, so this should not be having any effect. And furthermore, it doesn't run on the sample clock anyway. It has its own d-volume, so in theory, this should not be really related to at all, right? Meaning we should be able to ignore that loop pretty much completely. We then go ahead and check the sample position again. We say, let's start where we thought we were going to start. Let's go until we hit samples to mix more samples. That's not correct though, right? Because that's the place that we would get to. Samples to mix has been sort of determined. That's not actually what we wanted to do, right? In fact, we could just use the original value there if we were going to use that. What we actually want to do here, right, is sample position is actually getting updated in its own space. So if we wanted to loop over the number of samples we were supposed to fill, I would need, I would need a different value. So it's almost just a pure loop index at this point, which kind of suggests to me maybe I've architected this loop a little bit wrong. You know what I mean? But who knows? All right. So let's say we do that, plus loop index, like so. So now we know we will actually go over the number of samples to mix. And then again, we're still using sample position each time, and we're updating that by dsample. So all that is the same, but we're just controlling the number that we're doing. So then after we get out of that, we update the volume, obviously, which is fine, and check to see if we have to stop any volume ramping. Then we update the place that we are in the samples played by using whatever the samples thing was. And we then remove the number of samples that we mixed from the total samples, and we continue on our way. So let's take a look at that and see if that's a little bit more sane. Right? Pretty good, right? All right. So again, not particularly complicated, allows us to change the pitch. We can't change the pitch without changing the speed, but we don't really care about that too much. So we're pretty good there. There's not really a lot more that we need to really address. The only thing that like I said, I think we might want to do is get the bilinear filtering in there, just in case. I'm sorry, the linear filtering in there, just in case that smooths it out a bit. As you could hear, it really didn't sound all that odd, even just with the rounding. So we're not really in a position to be super concerned about that, but since it's pretty easy for us to implement, maybe let's drop it in. And how would we do that? We do that exactly the same way as we were doing it before. Right? All we're going to do is say, when we actually do this here, let's go ahead and floor. I assume we have that in our thing, right? Floor real 32. So what I want to do is I want to floor that sample position, right? To get what the sample index is. And then what I want to do is take a look at that fractional part too, right? So we've got the fractional sample position. That's going to be whatever the sample index was that we actually computed out here. It's gonna be the original sample position minus that. So that'll give me just the fractional part, right? That fractional part will now be a number between 0 and 1 that we can use to do the bilinear sample. So what we can do is we can take a look at both sample index and sample index plus 1, right? And in order to do that, we just need to say, okay, we've got two samples. They're both S16s, right? So we've got sample 0, and we've got sample 1. which is the exact same thing, just +1. And once we've pulled those two out, really all we have to do is upconvert those to real 32s, and then, so I guess I could probably just do it like this, right? Upconvert them from S16s to real 32s. Once I have them, I just need to blend them together by that fractional position, and we've done this a million times. We know exactly how we would do that, right? In fact, I think we even have a linear blend in our math thing that we can use if we just want to use the exact same thing. Lerp, right? Here it is. So if we want to lerp between those things, linear interpolation, here we go. Let's take sample 0. Let's go the fractional distance to sample 1. And that will become the sample value, right? And so we can even make this be kind of like an if sort of thing, right? We could do something like this, where we still leave in the old path as well. So, if we want to be able to A/B compare them just for our own edification at any given time, we could do that, right? So here we are playing the sounds. Let's say we're going to play the sounds at some reasonable delta, something like what we might actually want to do, not something super ridiculous. Of course, that's going to rear its ugly head occasionally. I'll be honest, I can't tell the difference. I cannot tell the difference between those two. Yeah, I don't know. That's a tough one. So, we could do it, we could not do it. I can't really hear the difference. We may need to get to other sounds at some point to actually be able to tell the difference. I don't hear really any artifacts in the other one either, so that's kind of rough. But it may just be because it's the wrong sound for it, honestly. So there's that. But honestly, that's just about it, right? That is pretty much the end of it in terms of capabilities that we really actually need in the sound mixer. This desample here we can read, right, out of our sound. So one of the things we probably want to do is have desample be in here on the sound, so that when you play a sound, you set that desample to whatever speed you want to actually play the sound at. We could also have that be something that you could pass in here as well, but not just not a little, just really not much that has to happen there. So we've got change pitch. And we've got the audio state, the playing sound, and it would just be basically like a desample or something like that for now. Maybe we can come up with a better way to phrase those in the future, but really, we're talking about that, right? So that's mostly it. Like, honestly, there really just isn't a lot more to it. There's maybe some edge case stuff that we want to look at there when we drop this down to SIMD, and we can just make sure the I's are dotted and the T's are crossed. But again, that's the code for a real-time streaming sound mixer with pitch shifting and volume, animated volume, right? Not a lot of code. Just not a lot of code. It's a very, very simple thing. So that's really all there is to it. Yeah. So I don't think there's really anything else to do there. We've got about 10 minutes left. So I think maybe, let's just use, since we were getting to that point where we want to use the live code editing, and it feels like the fact that that's going to cause problems with the threaded reload could easily make us grumpy, right? I'm wondering if maybe now would be a good time for us to make sure that that flushing stuff actually works, right? So if we have the thread procs here, we know what the queues actually are. So what we could maybe do is do some kind of a Win32 complete all work to force the queues to flush themselves out entirely before we actually do anything else, right? Let's just take a look at that really quickly, right? So when I do the load game code, right? Let's see Win32 load game code if compare file time. So Win32 unload game code. I'm just going to go in there to Win32 unload game code, and I'm going to say that maybe when we do the unload game code, and I guess I don't know, is the right thing to do it in there? Probably not. Maybe that's a stupid idea. So maybe what I want to do here is say, okay, right here we do the flush, right? So we've got the two queues, right? We've got the queues right here. So maybe what we want to do is just Win32 complete all work on the high priority queue, Win32 complete all work on the low priority queue, and see if that helps our situation, right? So here we go. Let's go ahead and change these values like we were doing before. Okay, so that did not help us. Let's take a look at what we're getting here as a problem. So the problem is that it's having trouble. Oh, okay. So this is actually just a string. This is actually just a string problem, right? This is actually a problem that has very little to do with what I was just talking about. I guess we were being kind of overly cautious there. So the problem with that is that file name was invalid, right? And we already talked about this when we implemented the live code ending. We said that file names wouldn't, like strings that were embedded wouldn't work, right? So when we actually build up this asset table, normally this wouldn't be a problem because that would be loaded in as data, which would persist. It wouldn't be part of the code. But our test code here actually has the problem because the test code itself, right, has the strings in it. So it's not a problem that would actually hit us once we get our asset system working, but until the asset system actually, I'm sorry, not the asset system, obviously the asset system is working, it's what everything's going through. The asset file actually defined and using the data from it, these strings will be a problem. So what we can do if we want to, right, is we could just say that those things are going to get loaded, that are going to get copied into our arena, right? So wherever we have a char star here, we could just go ahead and copy it because we've got the two places where it's used, add sound info and add bitmap info. Those are the only places that we would really have to deal with it, right? So when we set the info file name, we could just have like push string, right? In fact, did we already write a push string? We did not write a push string. So here we go. Inline void, I'm sorry, inline char star push string, like so. And then note Casey, this is generally not for production use. This is probably only really something we need during testing, but who knows. And here is the string to push. And then we just need the memory arena that you want it to go into, right? And so what we'll do here is we'll just say that, you know, we've got that assets arena, right? We've got this one here. So we can say that we want to use the assets arena to push the file name, and then that would take care of that problem because now they would be stored in our data store rather than in the unloadable section that gets reloaded. So when we do our push string, the only thing that we need to change about the way we were doing things, we can just do a push size, right, to get the string that we actually wanted. So we can actually just say, okay, we want to push something of the string length size, right? And then we want to, or I shouldn't say string length, but I'll just say size. And then the alignment can remain the default alignment. And then what we would do is we would just copy the characters, right? So we would say like char index equals 0, char index is less than string length, or I should say size, plus char index. And then we would just do this guy right here is the dest string. This would be the source. The dest gets pushed on, and then we just do dest char index equals source char index, right? So all we need to do is determine this size, and the size obviously is of a null terminated string. Unfortunately, there's no way to get that size without looping through it. Now, if this were production, if I was anticipating actually using this guy more, there's actually a trick you can do here to avoid the double loop. I'll mention it briefly. So if you look here, like we've got this thing passed in, we want to know how long it would be. So what I would actually typically do is something like this, right? Char star at equals source. While it's not null, we loop over, and for every character there, we add size to it. And obviously we also want to include the null terminator, so we would set the size to always be 1 at the start to include that null terminator. But what you would do if you wanted to be able to do this without the 2 loops, because you're pushing into a memory arena, in the single-threaded context, what you can do is just start actually pushing the characters into the arena, right? What the heck? Do you want to just do it? I don't know. Maybe we should just do it. Nah, it's not worth it. But point being, the memory's already sitting there, so you can just start copying it in, and then you can avoid the double loop. That's all I was going to say, right? So hopefully you can see why that's interesting potentially in some circumstances, right? So yeah. So anyway, that's all we really need to do there, I think. We should probably test that routine, push string. But when we come in here, okay, why did we never call push string? Did I not, in asset call it? Did I not? It's called right there. Why is it not? Oops, my bad. I was still thinking of the old naming scheme there, but there we go. Okay, so we come in here, we're doing test hero shadow bitmap, right? We loop over this and we just count what the size is. We get there, we say it's 26 characters long, so we push that. Is it? Can we call Sterlin? 25 characters long, correct. Stringling doesn't return the length with the null terminator, so we have the null terminator in there. So we go ahead and allocate that much. We then go over that many and copy it in there, and then we finish. Let's take a look at dest, make sure it's right. It is. So that is basically that. And while we are running, let's go ahead and do a little bit of tests of changing that rate again. Get a lot of reloads in there. All right. So hopefully that took care of that problem. Again, it's one that we said would be with the live code loop live code editing stuff. Is just that's one of the things you can't do is have data that's in the code block. And we should be able to avoid that most of the time because our strings will all come from the asset file, so we really shouldn't have to worry about that too much, but we have to worry about it temporarily while we have test code. That's just one of the costs of having test code, but test code is almost always worth it to get things right. So it's better to spend a couple seconds debugging some things than to not do it. So let's go ahead and go to the question and answer. If you have questions or answers about the stuff that we did on today's stream, please put Q: in front of it and ask it now so that I can answer it. Abner Coimbray, you said there were newcomers incoming yesterday, but then the questions were all pretty normal, actually, so I don't know. We'll see. We'll see what we get, certainly. Maybe the newcomers are all super smart and ask really smart questions, and they just look like they were people who've been watching the stream the whole time, but that's just because they super know what they're doing. You never know. They could have fooled us. How would you pan a sample slightly left or right in volume? Well, when we do the change volume, right, we have our change volume call in there. You would just decide how you wanted your volume to behave, if that made sense. Well, you know what? Let's just do it so you can kind of maybe hear it a little bit better. You know what I could also do here is I could maybe all right. Can you guys hear that better now? Is that too loud? I'll let you guys catch up for a second. But what I was going to say is, I think we have a debug mouse position, right? We pass the debug mouse position to the game, right? So what I was thinking is if we went into handmade.cpp, we could start playing with the pan stuff pretty easily by doing something like in, maybe in the game state here where we start looking at the input, what we could do, and by the way, I guess we could re-enable that if we wanted to. Now that our ground buffers recompute on the fly, that's probably pretty easy to do. Well, I guess I don't know because we don't want to touch ones that are in progress, so maybe I won't do that yet. Maybe I'll just leave a note to do re-enable this, but make sure we don't touch ones in flight. So when we come in here to do all of our controller stuff, maybe we want to do something where we'll do a change volume of that playing sound, that music test that we were doing, like so. And what we'll do is we'll just have a music volume value that we set. So let's see here. Game state, audio state. Is that the correct call there? So now music volume. What we'll do is we will set the music volume to be something that pans based on the mouse position, right? So we'll essentially say, well, I'm going to make a music volume. I'm going to set the 0 element of the music volume to be whatever the mouse position is. Handmade, let's see here. Handmade platform, mouse, mouse X, it is, right? So we'll take a look at the mouse X, and we'll say that we want to take the mouse X divided by, some kind of dimension, right? Whatever the dimension of the drawable buffer is probably what we would want to use. I would think for that. So maybe we'd say, what is that output buffer called? Let's see here. Render. Where is our render? There we go. So we could take a look at that draw buffer stuff, the buffer width, that's what we want. So if we were to do it by the buffer width, and this is just some temp code here, we'll do actually we could do a safe ratio 0, so to make sure that we don't accidentally get anything bad happening there. So we could just make it so that, I guess it would be the right volume. The further you move the mouse to the right, the more right volume you get. And music volume for the left will just be whatever the inverse of that is, right? So it's however much it would take to add back up to 1, right? And so again, we can sort of decide how exactly we want that to work. But so if we do that, then we should be able to micro pan it around pretty much. And then we also need to decide how fast we want that to happen. And I guess we want that to happen pretty quickly, right? So yeah. OK, so let's go ahead and what is this thing? V from V2 to K. So that goes second. There we go. Let's play it. Can you hear that? Right? So that should give you some idea of how you pan values slightly. This is using 0.5, 0.5, so half volume in either speaker when it's right in the middle. It's using 1.0 in the left speaker, right, or 1.0 in the right speaker, and 0 in the other speaker when it moves to the extremes. And again, this is exactly that same thing, that linear interpolation I was talking about. Basically, you're talking about going from 0 to 1 on one speaker this way, and you know, you know what? I'll just draw it on the whiteboard. Ha! As I draw, since we don't check to see if our app's active, it pans as I draw. Ah! I'm going to leave that on for a second because it's so darn ridiculous. So basically what I did there, right, is I said, okay, I've got from 0 to width of the screen, right? And I know that I get a debug mouse position because we sent the debug mouse position from the platform layer a long time ago saying, well, you know, maybe someday we're going to want to have some HUD stuff that you can click on to inspect in debug mode. The game's not playable with the mouse, not a mouse game, but we'll just shove the mouse in there anyway. So I was like, well, it's in there, we might as well play with it. So what I was saying is, okay, I can produce a value between 0 and 1 by just saying wherever I actually am, the mouse x, right, divided by the width will give me what percentage of the way I am there, right? So if I'm a third of the way there, it would give me 0.33333, right, as the value. So if I set that as essentially the right speaker, then as I move closer to the right speaker, it gets closer and closer to 1 and becomes full volume in the right speaker. Then what I can just say is, well, 1 minus whatever that is going to fill me back up to a sum total of 1 volume, so that would be whatever the left speaker should say. So as it gets, you know, closer to 0 on the right speaker by moving closer here, it gets closer to 1 on the left speaker, right? So I basically just did, you know, a standard thing, which was right volume equals mouse over width, and left volume equals 1 minus right, right? Hopefully that makes sense. Would this pitch shift be animated as well, like you enter a time-dilated area and pitch shifts in a second or as you cross a barrier? I don't think we really need that for anything in particular, so I would say probably best to leave it out of the loop because the pitch shifts are fairly subtle that we're aiming for. We're not set up to do big pitch shifts because, like I said, the time dilation would get you there. And so when you're talking about subtle pitch shifts, there's really not a whole lot of point in doing that ramping because you're not talking about changing between two large things where you get a lot of audible payoff from doing like a ramp, right? So typically we're just going to play sounds at a pitch and leave them there as a way of getting variety, but we're not going to do a lot of ramping. If you wanted to pitch shift the music without changing the speed, couldn't you just do a quick and dirty linear interpolation between the current sample and the next sample? That is what we are doing. That still changes the speed. Because the whole reason that it's getting faster is because you're moving basically the play cursor at a faster rate than 1-to-1 with the output. So the linear interpolation is just to avoid artifacts. It doesn't really do anything special. Garlando Bloom, can I ban everyone? Of course you can, you're a moderator. You have the power. How many years did it take you to learn how to code? That's a little off topic. Let me look to see if there's... Oh, there's a lot of questions here. I'm going to stick with on-topic ones until I can't see any more on-topic ones. Let's see. Meblo said it clips now, meaning when I turned the volume up on the audio, it was too high. Is that what you're saying? What are you saying clips? A little loud though because I'm quieter than it. Okay, so let's tone it down a little bit from there and maybe find a happy medium. Because since we're working on sound, I kind of want it to be somewhere there. So maybe we'll do it at 60% or something. Let's see how that is, and I'll play it back at its normal amount there. So it's playing at D sample. Oh, so it is already playing at the right sound level. Right. Let's see. Did you ever cover what would make a good test sound file for this type of mixing work? No, but if you really, if you're trying to do some very serious finaling of your audio, pure sine waves tend to be pretty good. Actually, you can hear things in pure sine waves pretty reasonably. Do you ever use memcopy from the C standard library? No. I mean, sometimes on the stream we have because we haven't gotten around to writing our own C standard library yet. But no, in my real life, no, I don't use memcopy. What's the yellow rectangle? The yellow rectangle was a placeholder because we don't have art for stairs yet. So we were testing some zooming code. Again, this is all just was test stuff that we were playing with, and so I don't know why it's a yellow rectangle. Don't ask me. We've got a bunch of stuff we're playing with that we're going to wrap up relatively soon, so there's a bunch of weird test stuff floating around in here that, you know, as you can imagine, is a bit odd. What kind of sound options do you plan to include in the game? Like, will the player be able to pause the game and mute the music, but keep the sound effects? Or is it going to be a fixed thing like controller settings? It'll probably be a fixed thing, I would imagine, but I don't know. Like, I don't really like the whole customizable thing that much. As I've said a couple times before, because, you know, like, you make a movie and you watch the movie, you don't go, I'm going to replace the soundtrack to this movie. Maybe it'd be a better world if you could, so I don't necessarily want to say that that's a bad thing to shoot for, but it's definitely not my preference. I like to experience the thing that was made. And so typically, you know, I kind of feel like the music is part of the soundscape and should be part of it. That said, the whole point of Handmade Hero is to hack on it. So every copy of the game will come with the source code. So for people who want to replace the music, I'd actually, rather than giving them a menu that does it, I'd rather encourage them to learn enough coding to go in and build the game and take out the music. Because that'd be a great project for somebody who just wanted an introduction to programming, to go in and just take out the one part that plays the music. That might be kind of fun. Kind of like the controller setting stuff. I kind of want to give people reasons to mod the game themselves, because it's supposed to be an educational project. Wouldn't you want to use the alternate way of animating the volume for this feature by setting a rate, not a length of time? Feature meaning the pan left to right? Assuming you mean the pan left to right, no. That's the exact kind of thing that I don't want to set a rate. Because what I want it to do is track the mouse exactly. So I want it to basically ensure that on a given frame it will go from its current volume to its new volume. But I don't want it to be a pop, so I just want to interpolate over some reasonable number of samples, which is what I set it to do, right? With a player running, would you connect speed of the player to pitch or look to add more sounds, i.e. more steps in grass? I would add more sounds for the footsteps, although the speed that the player is moving at, depending on the circumstance, could very well change the pitch as well, depending on the surface they were running on. So for example, if I run faster, I'm probably hitting the ground a little harder or doing other things. So pitch could vary with speed as well, but it wouldn't be the primary thing to vary. The frequency of actually triggering the footstep sounds would be the primary thing you'd vary first. Once you release the source code, this will allow people to build upon, edit, and make their own games, correct? Yeah, so actually, the way that it works is the source code's already available if you pre-order the game. You can already start hacking on the source code. You just can't ship it. You can't use it to make a commercial game because there's a time lock on it, basically. But that time lock expires 2 years from the ship date of this game. And at that point, it will be, you can use it for making any commercial product that you want. You may have already covered this, but does the OS alone allocate threads to run on each core so it is impossible to force a single thread to run on its own unique core? Actually, those are not mutually exclusive. So, yes, it is the OS alone which decides what core a thread runs on. So you are correct in thinking that you do not get to choose what core a thread runs on. However, because that can be important for performance-oriented programming due to the fact that certain caches are local to certain cores and other things like this, and who knows what else, right? There's lots of reasons you might care. Most operating systems, and Windows is one of them, provide you with ways of actually telling the operating system what cores you want your threads to run on. So even though it's the operating system that's doing the deciding and you are not writing the code that puts things on different cores, you can actually make calls. They're called affinity masks and things like this, where you can call and say, I want this thread to only run on these cores or this one core or whatever, right? And then while I don't actually know if it's a hard guarantee, meaning I don't know if Windows actually guarantees that it will only run on that core, it will create a strong preference in the scheduler, at the very least, so that when the operating system is scheduling the threads, it will try as hard as it can to run that thread on that core. And I'm sorry, I just don't recall whether Windows Scheduler guarantees you'll never run on the other core, or whether it just is a strong preference. But either or, the point is you do have some control there indirectly, and that so you can actually maybe not force a single thread to run on its own unique core, but you can certainly try. I mean, you can certainly do something like set all the other threads to have affinity to other cores, and set your thread to have an affinity to your core, and set the mask so that your thread can't run on the other cores or things like that. You can try to set up the circumstance so the scheduler just will actually do that thing. So you actually can do that. And there's other things. Windows has like a user mode scheduling thing, and they've added other stuff too. So you may have even more options than that. But at the very least, for all of for quite some time, Windows has had the ability to articulate to the scheduler what it was that you expect to happen in terms of distribution of your threads on the computer's cores. Is programming just you remember a whole bunch of commands and putting them into sequence? I probably wouldn't quite describe it that way, but it's not far from the truth. I mean, basically what happens is more like you build a mental model of how computers work based on the kinds of computers you're programming, and you know you have a certain set of ways you can affect their operation, and then it's you trying to figure out what set of those things you can do will produce the outcome you're actually trying to produce. So, you know, I mean, I don't know how you want to phrase that exactly, but that's you know, the rough idea. Let's see. Looks like that's the end of the on-topic questions. So we're running out of time here. Does anyone else have any top questions about sound I should answer before the time runs out of the stream? Anyone? Maybe Garlando Bloom already banned everyone, and so at that point it's true that we couldn't get very many questions, but is it too complex to add low and high pass filters via code? No. You know, I don't have a lot of experience with sound coding. I'm not really a sound coding guy. So I suppose I'm the wrong one to ask, but I believe it's pretty simple, actually. It's just a thing, you know, when we're outputting those sound samples, it's one of the filters you could run that's sort of just a in-place, pretty simple filter that just, as you output each sample, you do a little bit of math on it, and you use like accumulators to keep track of some state. So there's a little bit of bookkeeping involved, if I remember correctly, because you have to sort of know, there's sort of the concept, because it's a filter, it needs to have a window of samples to look at, because it needs to know what the oscillations are that it's trying to filter. So there's a little bit more bookkeeping that goes on if you try to start adding filters. That's usually the majority of the pain involved in implementing filters is, okay, now you've got to have a bunch of extra bookkeeping for them. But once you do, then it's just a simple set of math ops that operate on the bookkeeping and the new samples coming in, and that's really not that much more than that. So if you really wanted a low pass filter for some reason, it's not a huge deal to put it in. If a tree falls and the hero is not there to hear it, will it make a sound? Well, I guess it really doesn't matter if the hero's there or not. It matters whether the user is there or not, right? Because the sound is going to come out in their world. The hero can't hear any sounds because the hero is in a world where there is no such thing as sound, really. All of the sound comes out in your world, even though it's happening in his. So yeah, I would say that the sort of the Buddhist conundrum or whatever it is actually very simplified compared to what we have here, because our code is something like, if a sound happens, if a tree falls in your world and its vibration is reproduced in another world, but no one in that other world is there to hear it, did it make a sound? Soy Sauce the Kid asks, is the next thing you're going to do put the sound code in SIMD? Yes, I think probably what we'll do is we'll just lightly, we won't really spend a lot of time optimizing, but we'll just translate it to SIMD so we can make sure that it works wide, and then we'll probably call it good. And if we ever want more sound processing stuff, we'll revisit it way later in the game development cycle when we know exactly what sound features we don't have and want. But these are the only ones I really know that I definitely will make any use of. So we probably won't go nuts on adding sound features beyond what's here until we actually have some indication of exactly what we would want them for. So, are you going to use complex numbers? I heard they're useful for sound processing. So yeah, I mean, the whole complex number system thing is, if you're into digital signal processing, which is where a lot of sound stuff comes from, then all of that, the basis of all of that ends up being in sort of this complex number basis where, because of the way the Fourier transform works and all these other sorts of things, you get into places where it becomes convenient to think of things in terms of complex numbers. Honestly, I don't love digital signal processing. I feel like it's kind of cheesy. So, your mileage may vary. But if you want to implement the traditional sound processing code in the traditional way, yeah, you would want to go read about digital signal processing, which is based on complex number, usually uses complex numbers to talk about what it's talking about. That is really mostly for doing filtering sorts of stuff. You certainly don't need it for any of the stuff that we just did. Like, unless you're going to Fourier transform something to do some processing, you probably don't really need to worry about it. So, all right, I think I'm going to call it. Let's see here, because we're about out of time. Let's go ahead and close it down. Alrighty, close. Okay, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along at home with the source code when we are programming on the stream here, you can do that if you pre-order the game on handmadehero.org. It comes with the source code every day. I update it nightly after we're finished coding. So if you want to play around with it at home and just experiment and try to learn from the series, it's a good way to do that. We also have a forum site you can go to ask questions if you have questions about working with the code and stuff like that. It also has the annotated episode guide for catching up on past episodes, things like this. It has ports to Mac and Linux as well by members of the community that can help get you started if you want to work on a different platform besides Windows, so that's helpful too. We have a Patreon page if you would like to support the video series. We very much appreciate subscriptions. And we also have a tweet bot, which will tweet the schedule at you if you want to catch the series live. That is the best way to find out when it's going to be. So if you're interested in catching more of these streams, that's the place to check out. For now, I am going to sign off, but I will be back here, not tomorrow, because tomorrow's a day off, but Friday, 5 p.m. Pacific Daylight Time, same place on Friday. And I will probably be doing some work on changing the code over to SIMD so that we can make sure that that nothing that we did with the sound code is going to be confusing in SIMD, and we can make sure everything lines up nicely and just get everything kind of nicely buttoned down and be sure that architecturally it all works properly. So we'll go ahead and do that, and then we will kind of be able to check sound off our system, off of our to-do list until much later if we decide we want additional features. So that's pretty good. Pretty excited about that. And we can go back to buttoning up the asset system, which is basically just some memory management stuff at this time. So we're about to check off some pretty big to-do items, and that's pretty great. That would allow us to move on to some of the final stuff that we have before we can do game coding. So pretty excited about it. Things are going pretty well, I think, and yeah, I'm pretty happy with the progress that we've made. So give yourself a pat on the back. And I will see you guys on Friday. Have a good Thursday if I don't see you on the internet. Until then, happy coding, everyone.